Another thing is, boy, you can save on your wastewater bills. I had mentioned earlier, drain to waste. What does that mean? That when you're done watering, everything that comes out of the bottom of that system is just going down the drain, which means your soluble nutrients in a large part if you've been overwatering, and then anything that hasn't been uptaken by the plants. And by and large, there's a tendency to over nutrify systems. That's just kind of classic with farmers. But that excess material gets washed out. If it goes drain to waste, where is it going to go? If you're in any kind of municipal supply or with a wastewater treatment facility downstream, they aren't really set up to be able to handle potassium and phosphorus. So those are two big issues that you got to deal with. But if you can recycle your water and nutrients, you have a potential to basically eliminate any discharge, which could have to do with regulatory issues. If you can eliminate that discharge and prove to them, well, then there's another bill that you don't need to pay. Or that's the argument. You know, they're going to decide whether you can or you can't. But if it's based off of a volume thing, then you can cut it down to darn near nothing. And sure, maybe it's $5, whereas it was whatever it could have been, you know, hundreds, thousands, perhaps annually. And in addition, so this tank then is also built for aquaponics. It is purpose designed for that. And aquaponics, if you're not familiar with that, that's growing fish and using fish waste as part of the fertilizer, especially your nitrogen for plants. So boy, if you've got a wetland, what grows great in a wetland? Fish and other kind of wetland critters. It was really, you get one and you get the other. So by designing a wetland at the same time, we got aquaponics on top of it. Our largest units now are 1,800 gallons, and that is a big tank. That's 5 by 5 by 10. It's 4.8 cubic meters if you're metric, and that gives you a lot of reservoir to work with. In addition, if you want to get rid of excess nutrients, if you take in rainwater, you can use rainwater to flush, or you can just use your rainwater to, say you're working in a not enclosed situation. You can use rainwater, run it through the PermaCyclers, and then you wouldn't get CO2 back necessarily because that would most likely be vented off. But in an open agricultural or an outdoor situation, you got a chance to be able to capture all that rainwater, get it nutrified because of the wetland processes, the plants, the animals, everything that's doing their thing inside the tanks, breaking that material down, and then flushing that out to your fields, your low tunnels, your high tunnels. And like I was saying, so everything that gets broken down in one of these, one of the PermaCyclers in a wetland eventually becomes, as it turns out, a very beautiful soil amendment. Silt and loam that comes out of the bottom of the MRUs as you flush those things out because you're breaking down that material. It's a very active, very aerobic process, especially if you have things like, different kinds of fish, catfish or crayfish, a lot of macroinvertebrates, even snails and some salamanders in some cases. They really have the capability of breaking down that material and speeding that process up. And then everything that takes longer to break down. Labile is the term to be able to quickly be taken up. And recalcitrant's the term for it stays where it is, you know, it doesn't want to do anything. So this material that you're pulling out from the bottom is the recalcitrant, very slow to break down material that makes perfect soil amendments. And it already is biologically active and is capable of holding a fair amount of moisture. So mix that stuff in with whatever your preferred potting mix should be, and you're getting your soil back, basically recycling the plant almost entirely. Carbon dioxide gets gassed off, you got the nutrients free floating in the water, and then everything else that doesn't readily break down becomes your next potting mix. So these PermaCyclers can be used in conjunction with a whole lot of different forms of agriculture. You can see there's a picture of here over at my house, 2 PermaCyclers. Those are recycled and reclaimed MRUs from an old mining site because boy, those tanks really hold up. So we figured we'll just keep using them. And then you can see in detail there the high tunnel that we were setting up to be able to grow different kind of vegetables and plants and do some experiments throughout the winter. And of course, that's a high tunnel. Now, if you're using a low tunnel with even smaller air volume, then you can have the capability of dumping your waste CO2 into those low tunnels. So you can, as well as the heat and the humidity that's coming out of those, to give you more growing time, a longer growing season throughout the year. Of course, basic greenhouse, vertical agriculture and vertical integration. Light depth is another one where if you're using a greenhouse or a high tunnel, you can do light depth. Also, obviously, aquaculture and pond culture. If you have a pond that is slowly silting in over time, or doesn't have enough surface area to provide for the biofilm that are going to oxidize the ammonia to nitrate, this is a really good way to get you that surface area, because it's just a wetland in the box. It's a surface area that is going to do that nitrogen cycling. And this gives you the opportunity then to pull out that silt over time, turn it, that silt and loam, turn that into potting material, and then you get a double up on your agricultural benefits and outputs.